Perfect. Uh, all right, welcome to our introduction to password cracking workshop. My name is Sunny, and I'll be taking on this fun presentation, I hope. All right, here's the attendance link. Please make sure to fill it out. I've also posted the link in the chat. There's also a link for the workshop files for all the challenges that we'll be doing today, so please make sure to download that as well. I'll give you folks a minute. Okay, I hope everyone has filled out the attendance and downloaded the files. Yep, just making sure. Please make sure to download all the files we need for today's workshop. And let's get started. So for today's workshop, we're just going to be doing a quick introduction to hashes. We'll take a look at a program called John the Ripper, and we'll learn how to crack hashes using dictionary attack, creating custom rules, and then finally cracking password protected zip files and SSH keys. We'll also be looking over another password cracking program called Hashcat, and in particular, we'll be going over something called a Combinator Attack. For today's workshop, we'll be needing John the Ripper, Hashcat, Python 2, and two different word lists. First one's rocku.txt, and the second one's 3000 word list.txt. Everything should already be included in Kali. If you guys are using Kali, but if just to make sure, okay, just to make sure, please type in the word John to see it provides you something, and same thing with Hashcat, um, just to make sure you have it installed. All right, let's get started. So what are hashes? A hash is basically a way of taking any piece of data of no matter what length and representing it in another form that is fixed length to mask the original value of data. Um, Basically means taking a string and then jumbling it up into a certain length, just so the user doesn't know what that string represents. It can be done by running the original data through a hashing algorithm such as MD5, SNEFRU 128, HMAC SHA-256. They're all different hashing algorithms. MD5 refers to the message digest hashing algorithm that produces about 128-bit hash value. That means that no matter how big or small your string is, the output would always be 128 bits. It is mostly used these days for database partitioning and computing checksums to validate files sent across a network. Uh, then example is our SHA algorithm, which refers to the secure hashing algorithm. And in particular, SHA-256 produces a 256-bit hash, um, and and compared to MD5, it is quite slower since it's producing 256 bits as compared to just 128. SNEFRU 128 is also another type of hash. And as you guessed, based on the number, it produces a 128-bit output. It was invented in the 1990s, but didn't really got picked up by a bunch of people. It's still a hashing algorithm. So what makes hashes secure? Hashing algorithms are designed so that they only operate one way. That means that they're unidirectional, which further means that given a string, once you calculate the hash, it is not possible for you to revert to the original string by reversing the hashing algorithm. So as an example, let's take the word infosec. I'm just going to use Kali for that. Let's try the word infosec and pass it through hashing algorithm called SHA, right? You get a string, which is 128 bits. Now let's try switching this string up a little. Let's add a one. As you guys can see, it's a whole new string. Let's try an even minor change. Let's try capitalizing the C. And as you see, it's not the same as compared to the original infosec word. With that being said, each hash is supposed to be unique for every single word, no matter how small the change is. All right. With that, let's move on to our first challenge. Can you guys get me the MD5 encryption for the word password cracking and submit it to OrCid? I'll give you guys 5 minutes for this. And please let me know in the meantime if you have any questions. we're 4 minutes out. But if someone is struggling, you could do it on the terminal using the words MD5 SUM. Try following the same format as we did for the example. Instead, try using MD5 sum, and you should have the hash. I'll give it another minute. All right, moving on. Let's have a look at John the Ripper. So, who is John and how can he help me? John is not a person. It is one of the most well-known and versatile hash cracking tools. It is extremely fast to crack well-known hash types such as MD4, all the previous ones stated, and a bunch more. Um, I know I said in the last slide that hashing algorithms are one way that we cannot really take a hash and convert it to its original form. However, that does not mean that it is almost impossible to crack a hash. Um, Given that you have, let's say, a word and access to a hashing algorithm, you can create a dictionary using a bunch of words and passing it through that hashing algorithm, and then comparing those words with the hash that you have to figure out what word do you have. And for those who are wondering what NTLM hash is, it is a type of hash that is offered by Microsoft and is used by Windows to store passwords. And it consists of 16 byte strings, or about 256 bits. So let's have a look at John's man page per se. Um, I'll just post the link in the chat. If you guys want to scroll through it, it tells you exactly how to use it, what different features John includes, any updates, and then there are a bunch of links to figure out how to install it, what kind of modes there are, how you can customize John to your liking, different rules, and a bunch of examples. Right. So for us, so this is how John basically works. So you type in the keyword John on terminal, and then you type in a bunch of options based on what you need and then the path to the file containing the hash. So let's take an example. If you just search up John space help, it'll tell you exactly all the options that it can take. As you can see, there are a whole bunch of things that John does. Unfortunately, we won't be able to go through all of them in 2 hours, but please feel free to look at the man page for John and these options to figure out how you can use those. The ones that we'll be looking at are word list. We'll be looking at rules. Uh, show is something we'll be using a lot today. Uh, we could use fork depending on how complex the password it is that we're trying to crack. With that, let's have a look at an example. All right. So let's talk about something called automatic cracking. This is a feature of John in which you basically supply John with a word list and a path to the file containing the hash. And John will do a brute force dictionary attack on that hash to figure out what the password is. There are a bunch of different word lists available online, like we tell in our other workshops. So you could download a lot of word lists from this link right here. Feel free to clone the Git repository for later use. We won't really be using it today. Other than that, if you're using Kali, you guys can look at this file right here. Um, it already contains a bunch of word lists that you guys can use to crack different passwords. Now, looking at John particularly, and the automatic cracking, let's try cracking a password. Um, so I have something called a sample text here containing a password or a hash of a password. Let's see if John can crack that. So I type in the keyword John. I supply the word list that I want John to use. In this case, it would be RawQ, and then I just pass him the file. And John does his thing, and looks like that's the password. Now, sometimes John can be a little finicky when it comes to showing you the password. So, and it also says at the last line, use John or use the tac show command to display cracked passwords reliably. We're just going to take a look at this. Let's do John show. Looks like it's saying this password is SHA-1 password. And we just pass in the text file and right there. Looks like that is the correct password that we have. Does that make sense? Any questions? Okay, then let's give it a shot ourselves. So could you try solving challenge underscore one using the RockU text word list and automatic cracking? I'll give you guys about 5 minutes for this. All right. If you're struggling with this, let's try a little hint. Uh, so try using this command, except instead of path to file, try using challenge underscore one dot txt. And then for word list, just use the supplied word list. I'll show it right here. So that's the word list we're using. Okay, I hope most of you have gotten it. If you have any questions, please let me know. But let's move on. So automatic cracking, pretty easy, right? Let's try. Let's learn something about a format specific cracking. So this is another type of feature that John has. In this, we supply this specific keyword called tag format, and then we specify the format that the hash is in. So why do we do it when automatic cracking works, right? Like, why do we need to know what type of hash this is? If you look at all the warnings that John's giving us, that's why. So as you can see, John's saying that, oh, I've detected a raw SHA-1 hash. However, it says that it also recognized it as a raw SHA-1 AX crypt hash, or it could be a raw SHA-1 LinkedIn hash, or it could be a ripe MD hash. So these are all different types of hashes, right? Which means that John has to circle through all of these different types of hashes to come up with a reliable answer. Um, so in order to make John's life easier, we'll be using CyberChef today to analyze different hashes and give John the proper hash type based on whatever string we have. Let's take a quick let's do a quick example. So here I've got hash and sample2.txt and looks like it's a massive hash. Let's copy and paste it. Oh, nope, wrong paste. Forgot I was on Kali. Nope, still wrong. Whoa, what's happening?
You should be able to right click. Yeah.
Yeah. Okay, there we go. So looks like so this hash length is 128 bytes, or bit length is 512. And based on the length, looks like it's all of these, it could be any of these different types of hashes, right? Now let's take a look at SHA-512. Could it be that? Before we try a hash, I want to introduce you guys to this command right here. It's called John list equal format. So this command will list every single format that John is able to handle. So as you can see, there are a bunch of different hashes that John can crack, which is why we need to specify what type of format the password supplied in to make John's life a little easier and get us our password a little quicker. Um, for demonstration purposes today, every single type of hash you see would be a raw hash, which means it's a standard hash. We're not using any specific hash such as raw SHA-1 tag LinkedIn. I'm honestly not even sure what that's used for. I'm assuming LinkedIn has its own spin up of the SHA-1 hash that they used at some point. Um, or a Mozilla hash. Honestly, never heard of it. MongoDB, I know it's a database, but not really sure what kind of hash they use. So, as we saw in the sample, our password could be SHA-512, right? So let's see what John takes. What keyword would John need to solve for SHA-512? Let's try to grab SHA, or let's just try to grab 512. All right, looks like all of these passwords contain the word 512. Let's see if we can find. Ooh, okay. All right, looks like there's a raw SHA-512 format that John accepts, and let's try to use that. I'm just gonna clear it. So we'll do John format raw SHA-512. Then we supply a word list, user share word list rocku, and then pass in our sample 2.txt. Oh, all right, let's see. Oh, looks like John did something. Was it able to decrypt our password? We'll be using the show command as I told you guys a few minutes ago. Let's see. Nope, looks like that's not the right format. So we could go down the list. But since I encrypted it, I know it's actually a whirlpool hash. So let's quickly try and see if we are able to use use that. Let's try to grab whirl, and looks like John accepts this format. So we do the same thing, format whirlpool, supply a word list again, and pass in our text file. And looks like it did something. So let's try running the show command. And there we go. Looks like it cracked our password. Um, does that make sense to everybody? Any questions so far? Okay, no questions. Let's give it a shot ourselves. So can you solve challenge 2.txt using the rocku.txt word list? Try automatic cracking it and see if you can get the answer. If not, put it in CyberChef and see what you come up with. I'll give you guys 10 minutes for this. Time for a little hint. So if you try to cyber chef the type of hash this is, looks like it's giving you about 7 options. Um, Maybe try it from the top bottom or try bottom up instead of going top down. Could be one of the uncommon hashes. And make sure you do John tag list equal formats command to figure out how you're supposed to pass in that specific format. So as an example, if you want to pass in the tiger format, let's just try to grab tiger and see if John even accepts it. Looks like tiger's not an option. So that lowers our sample down to 6 different hashes. Okay, time for another hint. The password type is snafu. So let's try to grab snafu to figure out which snafu are we talking about. There we go. All right, so it looks like there are 2 different types of snafus there. Um, Given the bit length, can you figure out which one we're possibly using? I'll give you guys 2 more minutes. Okay, I really hope you guys are able to figure it out. But if not, I'll give you another hint. Try using something like this. Right, that command should do the trick. But moving on. All right, let's look at another feature John has. It's called the single crack mode. So far we've been working on doing dictionary attacks in which we're supplying John an external dictionary. In our case, that was raw Q. However, in single crack mode, John only uses the information provided in the username to work out as many possible passwords as possible. That was a funny sentence. But yeah, so as an example, let's go back to the days when we used to play Club Penguin. I'm hoping most of you did. Um, and we had to set a password. What would your password be? I know back then my password used to be my first name with like a 123 appended to it. I know not totally secure, but hey, it did the trick. Um, However, most people these days still use something like that as a password. So if we supply John the username, it can create its own dictionary based on different permutations or different additions or modifications of the password and figure out what the password is. So let's try a quick sample. I know I've gotten, uh, okay, so looks like I just got my hands on this password hash. And I know that it belongs to a user called the Joker, just Joker, I guess. So how do I format this thing to make John know that this password belongs to Joker and use our single attack mode? So first things first, I'm going to have to make a few changes to this text file. That being, I will type in the username with the colon and then the password. So in our case, it would be just the word Joker with a colon and then the hash. I save that, and now I just run John. I just use John single. Uh, I'll again, actually, I still need to figure out what format this password's in. So let's see. Okay, drop that in CyberChef. Okay, doing its trick. Looks like it's saying that it might be another MD5 hash. So let's just try with MD5. Before we do that, let's see how John takes MD5 as an input. We do formats. Let's grab MD5. And looks like there's a raw MD5 function that we can use. So let's run our thing. We'll use the tag single to specify we're using a single crack mode. And then we'll pass in the format. So in our case, it's MD5 and the file name. And looks like John did its trick. Uh, that's our password. But since John's recommending we use show, let's just do that. All right. Looks like for the username Joker, their password was the word Joker, except they substituted lowercase j for uppercase J and E for a 3. Not so strong, is it? Any questions? Okay. If not, let's try another challenge. Can you solve challenge 3.txt? I guess you don't really need the word list for this. That's my bad. Knowing that the username is Green Day. So try using the single crack mode and figuring out what type of hash it is. And then you already know the username. Give it a shot. I'll give you guys another 10 minutes for this. time for a little hint. Let's try to figure out what type of hash that is. So let's analyze the hash in CyberChef. There we go. Okay. First bet is it's SHA-1. Let's see if Callie accepts that hash. So we'll, or not Callie, sorry, John. Um, list formats. Let's grab SHA and see what type of, if we can find SHA-1. And looks like it does. With that, also another hint, make sure you type in the username Green Day with a colon right before the hash. And knowing the type of hash it is, just run the commands. I'll go back to the command page again so you guys know what to type right here. Okay. Let's try another hint. So since we've added the username at the front of our hash, and we know the hash type, our command should look something like this. All right, let's see what it does. And that's our password. Hope that makes sense. With that, let's move on. All right, let's look at creating custom rules in John. So defining a rule is basically using regex style pattern matching to figure out the passwords and to improve performance of John. Um, that being said, we use this when we are not sure what type of password, what kind of hash it is, and we just know like an approximate guess as to like what the password is. I'll give you an example in a second, but here are like the few basic different types of regex commands that we'll be using today. The first one's A under capital A, lowercase z. It means that you take the word or the password and whatever comes after, you append it to the password. A0 means you take the characters that we're defining and prepend it. So the characters that we define come at the beginning of the password. Lowercase c would capitalize the first letter and make sure, and lowercase is the remainder of our string. Capital C is the inverse of lowercase c, which means that it lowercases the first letter and capitalizes the remainder of the password. So, you know how we talk about the characters that we're defining? We do that by putting the character sets in a square bracket and then putting those square brackets inside double quotation marks. And here are a few different character sets that we'll be using today. First one's the 0 to 9. That means that it'll include all the numbers from 0 to 9. Just 0, or it could be any other number. That means it includes only that number. Uppercase A, tag lowercase c, it means that it includes all uppercase and lowercase characters. Both uppercase means only uppercase alphabets. Lowercase means only lowercase alphabets. Just a single alphabet means that it only includes that particular character. And then a bunch of special symbols. That means that the password can't include any of these symbols. There's a really cool website that tells you more about these different right here, different pattern matching. I'm just going to paste this website in the chat for you guys to look at. Right. As you can see, there's like a whole list on different types of regex pattern matching that you guys can do. But for the sake of time, we'll only go through a few basic ones today. Let's try a quick example. Uh, okay. Oops. Let's try to create the rule for the word infosec one at the rate. Oh, actually, sorry. Before we create a rule, we're actually supposed to create rules in a file called um, john.configuration or john.conf, and it should be in the etc john folder. So make sure that you have this file. If you can't figure it out, try using the locate command. So you can type in locate john.conf and it looks like it's in 4 different places. I'll be using the one in etc john. And if you open it, it should look something like this. And make sure you sudo open it, otherwise you won't be able to edit this file. All right. So this is the file that we'll be creating our rules in. Just gonna go through. All right. Everybody okay with that? Any questions so far? So just to reiterate, we'll be creating our rules in the etc john folder and then the john.conf file. It could either be the etc file or the user share file. If you don't have the etc folder, then try creating it in the user file. Otherwise, please open the etc file. And if you can't locate any of them, try using the locate command. With that, let's have a look on creating our first rule. So let's try to create the rule for the word infosec one at the rate. So first we will define the name of our rule. How do we do that? So let's try. All right. Looks like I already have a rule created here. All right, let's call it my rule. So we start with square brackets, list.rules, colon, whatever you want to call your rule, and then close square brackets. All right. So that just tells John that hey, this is a rule that's abbreviated as my rule. In the next line, we'll define our regex. So we know that the first letter in this is uppercase and the remainder of our string is lowercase. So we use the lowercase c with az. So C tells us that the first letter is uppercase, everything else is lowercase, and then that there's a one and an at the rate appended to it. Since it's being appended, we use the AZ format. If it was prepended, meaning that if it was something like 10 infosec, we would use the A0 command here. Then we have our double quotation marks, and then we pass in our different parameters. So we know that it's number one, so we type in the 0 to 9, and then we know it's at the rate, so we're just going to pass in a bunch of different characters. Let's see how it works. So I have that same thing copied right here, no change. Let's exit out of it. Want to save it. So I have sample4.txt. Again, it is a hash. Let's figure out what type of hash this is. Right, looks like it's an MD5 hash. We've dealt with those before. So we're going to use our John command. Then we type in our format. So in this case, it would be raw MD5. Then we type in our rule using the command rule, and then we call it a rule. So since we named it my rule, I'll do tag rule equal my rule. Please feel free to change the name. And then we just pass in our file. And we forgot our word list. Don't forget our word list. Word list, user, share. Word lists, raw.txt. All right, let's see what it does. All right, as we can see, it looks like it cracked our password. Let's just use the show command. All right, infosec went at the rate. Any questions so far? Okay, no questions. Then let's try something. Okay, can you solve challenge 4.txt knowing that the password contains these parameters? So it begins with a lowercase character. The rest of the word is uppercase, and it is appended with two numbers. So try creating a regex style pattern matching in john.conf file and then run that rule. I'll give you guys 10 minutes for this. Let me know if you have any questions. Okay, so I totally lost track of time, but I'm hoping we're at the 5 minute mark. I'll give you guys a quick hint. So let's clear it. Let's try to figure out what type of hash this is. Okay, drop it in CyberChef, and looks like it's a SHA-1 hash. So we've worked with that before. Our next task should be creating a rule. So for that, feel free to add it in the john.conf file. I usually do them at the very end, but you could do it anywhere as long as it's not in a function. So let's call it challenge, and then just type in your regex pattern matching right here. Right, I'll give you guys another 5 minutes for this. All right, time for another hint. So let's look at the parameters for our password. We know that it begins with a lowercase letter and that the rest of the letter is uppercase, right? Um, so if we go to our guide and we look at this capital C command, it tells you that it lowercases the first character and uppercases the rest, right? So that means our string has to start with a capital C, right? Next, we know that words are being appended, or our password is being appended with two numbers. That means it's at the numbers are at the end. So, uh, right? Let's see here. Nope, it's not in this part. It's probably in another part, but we're just going to see the slides. All right. If it's being appended, that means we're going to have to use the AZ command, right? And then it's being appended with 2 digits. So we know the digits could be either 0 to 9. So maybe try typing this twice in double quotation. So let's just try doing it. So we got capital C, AZ, then we started quotations. And inside we got 0 to 9 for our first number, and then another 0 to 9 for our second number. Now, all we need to do is run this in John using something like this. Except call your rule to whatever you named it. So in our case, that would be the word challenge. And see if you can figure it out. I'll give you guys 2 more minutes for this. Right? Let's see what happens when we try to run this. Uh, okay, looks like it's running. About 2% done. Well, it looks like it'll take 3 minutes to do this. 2 minutes now. There we go. All right, looks like it cracked our password. But since John is forcing us to use the show command, let's just quickly do that as well. And yep, that's the password. All right. Any questions regarding this, folks? Okay, if not, let's move on. All right. So we know how to crack a password that contains, or we know how to crack a hash, right? But we let's be realistic. We can't really get access to someone's hash that easily. In a more realistic scenario, when we're playing CTFs or just trying to pen test something, we'll probably come across something called a password protected zip file. So as an example, let's take a look. So something like this. There's a file that looks like it's logged, and then it needs a password, right? Now, how can we crack this password right here? Clearly, we don't have access to a hash here or anything of the sort. It's just a zip folder with a random text file. So what can we do? For this, we can use something called zip to John. Um, it is another tool provided by John that converts a zip folder to an output file or a file that contains the hash, and then we can pass that output file to John for it to crack the password. So let's take our sample 5 zip and see how we can do it. Uh, desktop, terminal, I guess. Let's just see if we can find zip to John first. So I'm just going to do locate zip to John. And looks like it's just in user as bin, which means I should be able to run it without any path. So I take zip to John. I take my zip folder and I just create a random file. I'm calling it output5.txt. You could call it whatever you want. And then this greater than symbol, it means that whatever output sample dot this command does, the zip to John space sample5, you store that output in this text file right here. So looks like I'm done. Let's take a look as to what output 5 looks like. All right, a bunch of gibberish. We have no idea what it means, right? Well, John does. So what we'll do is we'll do John. We'll supply a word list. Uh, user share word list rock you, and then we just pass our output file. Let's see what happens. And looks like John did something. So let's just use John's show command. All right. So file is called sample5.zip. It contains one text file and it's encrypted with this password right here. Carrie Ann Beck October. So let's see if this password actually works. Copied it. I'm going to paste it. Okay. And looks like it does. And we're able to read the content. All right. Then there's another tool provided by John. It's called SSH to John. This tool is used to crack our private SSH key files. So I'm hoping everybody knows what SSH is. If not, an SSH key is basically an access credential for an SSH network protocol. If you've been in 329 or 525, CPSC 525, during like the beginning of semester, I'm pretty sure Dr. Henry asked you folks to upload your SSH public key to Mocha. Um, so what does an SSH key do? Think of it as so there are two different things when you generate an SSH key. You get a public key and a private key. A public key is sort of like a digital padlock that lets you access a server. So instead of you having to input your credentials each time, you just have this private key on your local machine that will authenticate on the server for you, right? So let's say you got access to a private key, and I know these days that private keys also have like a password stored into them. So even though you have the private key file, you still need a passphrase to actually access a remote server. So what we can do with John is we can use the SSH to John tool to to crack these private key files. The command for this is almost identical. Not why am I saying almost? It's literally identical. So to zip to John. So let's try to locate SSH to John. Looks like it's in user shared John. So all you have to do is just put in the path user shared John SSH to John, and then whatever SSH file you're passing. I didn't really put a sample for this since it's almost identical, but it should be an IDRSA file. You pass it to a text file and then use John to crack the code. Okay. Any questions? Okay. If not, can you guys solve challenge 5.zip and challenge 6.idrasa using the Rocky word list? For challenge 5.zip, you'll find the flag inside the text file. For our challenge 6, just submit the flag as UCSec and whatever password it is for the private key. I'll give you folks 10 to 12 minutes for this. Please let me know if you have any questions. Okay, time for a little hint. So for the zip file, let's just use zip to John. Let's say challenge 5. Let's just actually, I'm just gonna cd to challenges to make this easier. So zip to John, challenge 5. Let's just call it output 5.txt. And it did something. Let's have a look at output. And looks like we have something there. Now we'll use the same thing for SSH key. We'll do SSH to John, challenge 6, output, let's just call it 6. All right. And all right, looks like we have two different files. Now, all we need to do is John, supply our word list, rock you, and then just pass in our two files. So the first command would just be John space word list output 5. Second would be output 6. All right. Give this a shot, see how it goes. I'll give you folks another 2 minutes. Okay. Um, I hope most of you have gotten it. If not, these are the commands. I'll quickly go through them again. So for the zip file, just do zip to John, challenge 5, and then just output it to an output folder or an output text file, and then do the same thing for SSH to John. All right. With that, let's switch gears and move on to Hashcat. So, what is Hashcat? It claims to be the world's fastest CPU and GPU password recovery tool. I honestly have not seen any performance improvement as compared to John. They're both pretty much the same thing. Um, just like John the Ripper, it supports a bunch of different hashes, LM, NT, Kakak 256, SHA-1, and many others. I think it supports around 355 different hash types. Now, let's take a look at how Hashcat works. And why are we talking about Hashcat when John works perfectly fine, right? So, just exit out of it. Let's call hashcat help. All right, let's just go through its documentation real fast. You can see it's quite lengthy. All right, so hashcat. I'm using version 6.11. Hopefully, you all are too. So there are a bunch of different argument types. If you guys can tell, it's way more argument types than John. I'm honestly not a pro, so I'm not even sure what half of these, not half, like what 90% of these do. The ones that we'll be looking at is hash type, attack mode, and that's it. All right, let's look at different hash types, or hash modes. So Hashcat takes in a bunch of different hash types, as we can all see here. And just like John, it keeps going and going, right? And let's look at attack modes. So this is what makes Hashcat a little bit different than John. Hashcat has something called a combination mode, that we'll be looking at today, and it does pretty cool stuff. So let's get started on that. So the basic usage of hashcat requires a minimum of four different arguments. Um, so we start with the word itself, called we call hashcat. Then our first argument is tag m or tag hash type. So tag m tells what type of hash we're cracking. As mentioned earlier, Hashcat currently supports about 355 different hashes. Argument two is our tag A or tag attack mode. This tells the argument which type of attack we're trying to use. As an example, A0 represents a dictionary attack, much like what we did with John earlier, and A1 represents a combinator attack. Then our argument three is the file name or the hash name, or that specifies the hash or the file that contains the hash or multiple hashes that we intend to crack. Argument four specifies our word list. So um, we've been using RockU so far. So in our case, again, it would be RockU. So overall, we use it like hashcat space m, whatever hash we have, attack mode, attack mode, path to file, path to. Now, why are we talking about hashcat? As mentioned before, hashcat has this special feature called a combinator attack. So what does it do? We've been working with a word list so far, right? And each word list, or the word list contains a word in every single line. So it's pretty easy for us to run a dictionary attack, given that word list. And then if our password is, a word from that word list. However, most users these days don't really use dictionary passwords. I know people who try to combine a bunch of different dictionary words and try to substitute a bunch of different letters to make their passwords more secure. Um, in our case, let's take an example. Let's see the word hello there. It consists of different dictionary words called hello and the word there. So using combinator attack, we can pass in two different word lists at the same time, and Hashcat will do different permutations on those two word lists and try to come up with an answer. So how does this work? Usage is pretty simple. Just like the basic usage, we type in the word hashcat, or hash type, the word or attack. So in this case, we're using combinator attack. So it would be number one, path to the hash, and path to word list one, path to word list two. So let's see a quick example here. Um, I have I have sample seven, and looks like it's a hash. First of all, let's go to CyberChef and figure out what type of hash this is. All right. CyberChef says it's MD5, possibly MD5. So let's look at Hashcat's documentation now. All right. So looking at MD5 looks like it can be represented with number 0, right? So let's run Hashcat. M0 to specify the MD5 hash type. And checking the question so far. Oops. Right. And then tag A, 1. Why did I put 1? Because 1 represents combination attack. And then our sample. So for this one, I'm using the 3000 word list. This one's provided with you in the zip file that I asked you guys to download. So overall, we've got 5 different arguments. We've got our tag M that specifies that it's an MD5 hash, tag A specifying we're running a combination attack. Then we've got our hash, we've got our 2 different word lists. So let's run it and see what happens. Right, looks like it found something. So let's run our show command. So sample 7, and looks like that's our password. Accomplish awareness. Now, just to make sure that this entire string is not in our word list, I'm just gonna do a quick grep on our word list. Accomplish awareness, and looks like there's no word like that. However, if we try to grab the word accomplish, that exists. And if we try to grab the word awareness, that exists as well. So Hashcat permutated through all different combinations in the same word list, and it was able to crack this combination password. Does that make sense? Any questions? Right? No questions? Then let's try our final challenge. Are you able to solve challenge 7.txt using the provided 3000 word list text file? Hint, it's a combination attack. You guys have about 10 minutes to do this, and let me know if you have any questions in the meantime. Let's try a quick hint. So let's see what type of hash this is. Just gonna throw it in CyberChef. And again, looks like it's an MD5 hash. So our command shouldn't be as different, much different from sample. All right. So we type in hashcat, tac m 0, tac a 1, m 0 because it's MD5, a1 because it's oops, a1 because it's a combination attack. Then we throw in our file. In this case, it would be challenge 7, and then our word list. All right. Try this command and see if you guys can get the answer. Right. Another, well, let's see what happens if we run it. Right. Looks like it found the hash. Let's do show. And that's our password right there. Right. I hope you guys were able to crack it as well. With that being said, we're done for today. Thank you everyone for attending.
Thanks, Sunny.